Hi guys, and welcome to my video on the converse of the Pythagorean theorem. So the Pythagorean theorem is a very popular theorem in mathematics. It's one of the most proven theorems in all of mathematics, so much so that even a former president of the United States is credited with authoring a proof of the Pythagorean theorem, showing why it works. And let's talk about what the converse is going to be for just a second, and then we'll get into some practice problems. So what you're seeing here, this is a very typical model of what we would say for the Pythagorean theorem of what it is. Meaning that here, in this case, I drew this in such a way that it is a right triangle, and this is a very popular Pythagorean triple, a 3, 4, 5 right triangle, where what we were seeing in the Pythagorean theorem is that the sum of the two sides squared for a right triangle would be equal to the square of the third side. And that is exactly what we're seeing here, because if I take the 3 and I square it, I get a 9. And if I take the 4 and I square it, I get a 16. And if I take the 5 and I square it, I get a 25. And 25 is indeed equal to 25. And that's what we do with the Pythagorean theorem. Well, what the converse of the Pythagorean theorem does is it allows us to use the sides of the triangle to classify a triangle either to be obtuse or acute. So we don't necessarily need to know the angle measurements. Now, this converse is kind of based on what we've seen with the triangle inequality theorem, where we show that the sum of the two smaller sides must be greater than the length of the third side to have a triangle. And how we're going to use those sides now to show whether or not we're going to have an acute triangle or a right triangle. So this is the next one that I have for you here. Okay. So this triangle I drew again with two sides of 3 and 4. And I measured an angle of 110 degrees. Well, when I measured the third side in this case, I got about 5.2 centimeters. And clearly, because I measured this to be 110 degrees, I know that this is obtuse going into it. However, according to the mathematics that we have here, if I take the sum of the two smaller sides and I square them, in this case a 9 and a 16 again, and I square the third side, in this case, the sum of the two smaller sides is going to be less than the third side. Or you can think of that the third side is going to be greater than the sum of the other two sides put together. However you want to think of it, but I kind of like to think of it in terms of the third side being greater than the sum of the other two sides, because it's just easy to think of that third side by itself. So if the third side is going to be greater than the sum of the other two sides, then that allows us to justify that the triangle that we have created will be an obtuse triangle. Well, we got one more that we can kind of look at here, and I'm keeping in the same dimensions. Here I kept the side length of 3 and the side length of 4, so the squares that would be made off of those with the sum of the two squared, or the side squared there represent, oh, sorry, my computer is freaking out on me here. When I measured the third side, I got about 4.1 centimeters, giving me about 16.81 centimeters squared. Well, because I'm keeping these two sides consistent, I still know that, one side squared is still 9 and the other side squared is still 16. But in this case, the third side squared was about 16.81. And clearly, this time, the sum of the two sides squared was greater than the sum of the third side squared, meaning that when this value, when that third side is less than the sum of the two smaller sides squared, that means that we are going to have an acute triangle. And so now that brings us back to what we're going to see with our practice problems. So first of all, what we're going to be able to say is that the Pythagorean theorem, and I'm going to, normally we write it as a squared plus b squared equals c squared. So I'm going to keep it that way. I'm going to say a squared plus b squared. If it was equal to c squared, that gives us a right triangle. However, as we just showed you, if I have the sum of the two sides squared, and the third side is greater than those two sides squared, then that means the triangle will be obtuse. And the other way of writing it is that if the sum of the two sides squared, the two smaller sides, are greater than, or the third side is less than the sum of the squares of the other two sides, then that means the triangle is acute. So personally, I like to think about it in what is the third side going to be compared to the other two sides? Is it equal to the two sides, greater than the two sides, or less than the two sides? And that's how I determine whether it's going to be right, acute, or obtuse. So let's take a look at a couple problems here, and I'm going to do the first four. There's 8 examples that we're going to take a look at, and I'm going to do the first 4, and then I'm going to ask you guys to try and do the last 4 on your own, just to see how if you're able to, understand it and demonstrate that understanding by working the problems out yourself. Now, in this case, what it's asking us to do is first determine if the side the 3 sides that they're giving you could even form a triangle. And again, this comes directly from the triangle inequality theorem that says, the sum of the 2 smaller sides must be greater than the third side in order for us to have a triangle to begin with. So that's what I'm going to check first. The 2 smaller sides in this example are 3 and 7. So 3 plus 7, is that going to be greater than 9? And it is. So that means I do have a triangle that I can form with these side lengths. So now I'm going to plug those in, and I'm going to say the 3 squared plus the 7 squared. Now here I don't know what I'm going to put. I don't know if I'm going to put an equal sign or a greater than sign or less than sign yet. So I'm going to just leave that symbol blank for the time being. And then we have the 9 squared. Well, the 3 squared gives me a 9. 7 squared gives me a 49. And we're going to just leave this blank again for now. And then the third side here gives me an 81. So if you take the sum of the 2 sides, the 9 and the 49, that's going to give you a sum of 58. Which is clearly less than 81. So what I'm looking at here is I'm saying that the third side is greater than the sum of the 2 other sides. And according to what we're seeing here, if the third side is greater than the sum of the 2 other sides, then that allows me to say that this particular triangle is obtuse. So let's try another one. Let's try this next problem here. Again, I want to know, is this going to make a triangle? And this one should be pretty clear that it'll make a triangle because 20 plus 21 is 41, and 41 is definitely greater than 29. So we definitely have a triangle here. Well, now we're going to say, okay, well, what type of triangle do we have? So 20 squared plus 21 squared is going to be something to 29 squared. We just don't know what that is. That's why I don't want to put an equal sign here or anything like we would normally do when we're working out a problem, because I don't know what type of symbol I have here yet. So 20 squared, that one's easy. That's 400. 21 squared, I don't know. I don't have that one memorized. That's 441. And the third side, 29 squared, is 841. So the sum of these two sides, 400 and 441, will give me 841. And I have an 841 on the right side also, so that means these two values are equal to each other. So this particular triangle must be a right triangle. So now let's take a look at examples 3 and 4. So first of all, in example 3, do I have a triangle? Because if I don't have a triangle, no point in trying to figure out whether it's right, acute, or obtuse. So the sum of the two smaller sides, 4 and 11, need to be greater than the third side, 16. And in this case, the 4 and the 11 are only going to make 15, and 15 is not greater than 16. So in this case, I do not have a triangle that can be created with those three sides. So the next one that I'm going to work out for you is this example number 4. And again, I'm going to kind of, do I even have a triangle? 17 plus 17. This one should be a little obvious. 17 and 17 are going to give me 34, which is definitely greater than 22. So I know I have a triangle that I can form here. In this case, because I have a triangle, this is going to be isosceles, where these two sides are the same. So this side of 22 would be the base of the isosceles triangle. But that's not what we're trying to figure out, because we can have right, obtuse, or acute isosceles triangles. So 17 squared, the sum of the two smaller sides, and 17 squared need to be something greater than, equal to, or less than 22 squared. So I don't know what 17 squared is. That's not one I see a lot. So that's 289 plus another 289. And then the 22 squared gives me 484. So the sum of the two sides, the 289 on the left side gives me 578. And 578 is greater than 484. So in this case, the third side is less than the sum of the other two sides. And according to what we have up here, when the sum of when the third side is less than the sum of the other two sides of the triangle, then that means that this one is going to be acute. So at this time, I want you guys to go ahead and pause the video, and there are 4 more examples that I'll make sure that you can see here. There's 4 more examples that I want to make sure that you guys get some practice on your own to see, how you can classify the triangles according to the converse of the Pythagorean theorem. So go ahead and work out these 4 examples, and when you're done, hit play again and check your work and see how it compares with mine. So how did you do? Hopefully you did what I asked you to do, and you paused the video and you could work out these last 4 problems to see how we can classify the triangles. So in problem number 5, we wound up with a right triangle. In example number 6, 23 is not greater than 23, so the 3 side lengths on 6 did not form a triangle. On 7, we wound up with the sum of the two smaller sides to be 2186, and the third side was 1521, so the third side was less than the sum of the other two sides, so we have an acute triangle. And then the last example, the 11 squared plus the 19 squared gave me 482, and the third side squared gives me 784, which is clearly larger than that, 482. So that's how I'm that's the justification to classify the triangle as obtuse in this case. So that is essentially what the converse of the Pythagorean theorem is. It's a way of justifying whether or not a triangle, if it's not going to be right, whether it would be obtuse or acute. And that's where we're going to wrap things up for this. So thanks for watching. I hope you learned something. Take care, and we'll talk to you soon.